Assalamu alaikum and hello. My name is Wan Farah Fatihah binti Mir Ahmad Zubir. I'm from AT117 4A, and this video presentation is presented to Dr. Muhammad Izwan bin Ismail. Title of this article is Effects of Water Depth on Growth Performance of Indian Megacarps at a Polyculture System in Bangladesh. The authors are Muhammad Hafiz Al-Hussain, Khausik Sakhir, Muslim Sakhir Chanda, and Nipa Gupta. Introduction. The study was conducted to evaluate the effect of pond depth on the growth performance of Indian megacarp species, which are Gibellion catala, Lobiorohita, and Serhinus mrigala. The carp species was be chosen because of the high growth rate, ease in reproduction, tolerance to environmental stress, and its market demand. There is no previous study ever done this research, but there is a study about the effect of water depth on Nile tilapia fingerlings and adults, which resulted on growth performance, and the survival rate was significantly affected. The water quality like temperature, transparency, turbidity, water color, carbon dioxide, pH, alkalinity, hardness, unionized ammonia, nitrate, nitrite, primary productivity, BOD, which is biochemical oxygen demand, which the amount of dissolved oxygen needed, and plankton population must be considered in any fish farming. Hypothesis. Null hypothesis. There is no effects of pond depth on the growth performance of Indian megacarp fishes, while the alternative hypothesis is there is a significant effect of pond depth on the growth performance of Indian megacarp fishes. Objective. The main aim of this study was to assess the effect of water depth on the growth performance in terms of length and weight of table-sized Indian megacarp, which are Gabellion catla, Lobiorohita, and Serhinus mrigala fishes. Treatments. The experiment was carried out for a period of 8 months during the 1st February till the 30th September of 2016. The treatments have been used were three. Treatment 1 is 1.2 meter, treatment 2 is 1.8 meter, and treatment 3 is 2.8 meters. The stock of fish fed at morning and afternoon daily at the rate of 5% body weight with commercial pellet feed. The shape of these ponds was rectangular, with a total surface area of 650 decimals. Each pond had a watering inlet but no outlet, and free of aquatic vegetation, well exposed to sunlight, sandy loam at the bottom. The method used in this experiment was randomized complete block design (RCBD). Replicates. There were two replicates for each species of catfish. There were 6 different ponds located at Niyamatpur to Gurgaon, which explain one species using 2 replicates, which are 2 ponds. Experimental design. The flowchart showed us the process of the experiment contained the pond preparation, stocking, and post-stocking management. For pond preparation, first thing first, the ponds were dried and any aquatic vegetation were vacated. Then, liming was done after drying, and the use of lime improved the pH and alkalinity in aquaculture ponds. It disinfects pond bottoms and water to attempt the control of pH. The ponds then were filled with the groundwater. After 7 days of liming, fertilization was done. The ponds were added with urea and triple superphosphate (TSP) at a rate of 39 and 37 kg per hectare, respectively. Then, after 7 days of fertilization, Sumithion was applied in all ponds at a rate of 25 liters per hectare. It is an organophosphate insecticide which is widely used in aquaculture ponds for the eradication of aquatic insects. Stocking. Before stocking the fishes into the ponds, acclimatization of temperature was done where the containers were kept floating for 30 minutes to ensure the carp fish didn't face any stress for sudden temperature changes. The weight was measured and recorded to determine the feeding dates of fishes in each pond. For the post-stocking management, the fertilization was done every 2 weeks with 25 kg per hectare of TSP, which was dissolved for 24 hours, then 50 kg per hectare of urea, which was dissolved in a bucket in the morning, then applied by spreading on the surface. The parameters in water like water temperature, transparency, water depth, dissolved oxygen, and pH were measured at the pond site on each sampling day. Experimental unit. This is the review of the pond site. Since those carp fishes were grouped in the ponds and all fishes within that pond received the same treatment, which in terms of water depth of 1.2 meters, 1.8 meters, and 2.8 meters. Then the experimental unit would be these three species of fish, which are Gibellion catula, Lobiorhita, and Cyrrhinus megala. Despite that, the article showed that the replicates, which are pond, are two for each species, but it doesn't really make sense when they proceed with two ponds and three different water depths for each species at one time. In my sight, the pond should be three for each if wanna do this experiment smoothly. So I assume that they done it with a method that didn't mention in the article. Results and discussion. As we can see on the graph, it was observed that Gibellion catla, Lobia rohita, and Serhinus brigala fish cultivated on 2.8-meter depth of water yielded higher fish weight, while compared when the fishes cultivated at the lower depth, which is 1.2 meters and 1.8 meters. Therefore, it was recommended that these carp fishes cultivated at higher water depth, which is 2.8 meters, than at the lower water depth, which is 1.2 meters, to gain more benefits. As we could see on the graph, the length of the three species of carpfish was found maximum when it was cultivated at 2.8 meters depth of water, and minimum was found at 1.2 meters depth of water. It was concluded that the carpfish cultivated at higher water depth generate fish of larger in length, while compared to the carpfish cultivated at lower water depth, yielded fish of smaller in length. As we go through the graph, we can conclude that the highest average of survival rate was observed at T3, followed by T2, and the lowest survival rate was recorded in T1. However, the maximum survival, which was 99.23% rate, was found for Lobia rohita fishes at T3, and the minimum was found for Gibellion catla, 95% at T1. Discussion. First, temperature. The optimum growing temperature was 25 till 30 degrees Celsius, at which they grow quickly. In July, lowest temperature was recorded at 18 degrees Celsius, while the highest temperature is 30 degrees Celsius in May. Second, dissolved oxygen. Dissolved oxygen level greater than 5 ppm is essential to support good fish production. In February, T1 recorded the lowest dissolved oxygen, which is 5.4 ppm, and the maximum was recorded 9.07 ppm in month of July at the T3 treatment. Third, transparency. The optimum transparency was 25 till 40 centimeter. The lowest transparency was recorded at T2 treatment in February, while the highest transparency is at T2 treatment in July. However, the transparency at 36.2 cm in carp polyculture pond is the best. Fourth, pH. The maximum growth of fish occurred at a pH range of 7.6 till 8.6. The lowest pH was 6.7 recorded at T3 in July, and the highest 8.6 was recorded at T3 treatment in February. Conclusion. In conclusion, the results of this study indicate that the carp fish grown at 2.8 meters water depth will help farmers and be economically more affordable compared to the 1.2 meters and 1.8 meters water depth. Therefore, we accept the alternative hypothesis and reject the null hypothesis.